Hey, so we're going to look at complex numbers, also known as imaginary numbers. So imaginary numbers come up specifically in the context of square roots. There are some things that we just cannot take the square root of. So we know now that square root is opposite of something squared. So if I want to take something like the square root of -4, that would mean that there is a number that I could square to give me -4. But there isn't. If I square a positive, I get a positive. If I square a negative, I get a positive. So there's no way for me to actually square a number to get a negative number. So currently this doesn't really exist. It is imaginary. Same thing with the square root of -6. Same thing with the square root of -1. I cannot square anything to give myself a negative number. Okay, well, I'm going to see instead, I still want to be able to simplify some of these things. So I'm just going to call it something. I'm going to call it I for imaginary. And I'm going to go with the most basic negative. I'm going to have the square root of -1. I'm going to say that's I. So I is an imaginary number. It's a complex number. And it is the square root of -1. I can at least use that now, the fact that I equals square root of -1, to simplify these imaginary radicals. So I know square root of -4. Well, let's see, I know the square root of 4. So square root of 4, I'm going to write that separate. And now I know the square root of -1 is the same thing as I. So if I look at this, I could simplify this to 2I. Square root of 4 would just be 2. Square root of -1 is the same thing as I. If I look at the square root of -6, I don't know the square root of 6, but I can again rewrite it as square root of -1 times square root of 6. So I can write that as I times the square root of 6. Which at least now the thing underneath the radical is real. It's not imaginary. Okay, I'm going to try to simplify a few more real quick. Say I have the square root of -18. I can write that as the square root of -1. Get my square root of -1 out right away. Square root of 18, there is a perfect square that multiplies, so square root of 9 times square root of 2. Okay, so if I have the square root of 9 and the square root of 2, I can make that 3 square root of 2, and that square root of -1 again is an I. I'm going to write it as 3I square root of 2. Okay, we're going to try it again with the square root of -30. So I can rewrite that as square root of -1. And I can't think of any sort of perfect square that multiplies to give me 30. So I'm just going to keep it as square root of 30. So that'll be I square root of 30. Square root of -x is 6. Again, I can write that as square root of -1 times square root of x is 6. I know square root of x is 6. That's x cubed. So I have I x cubed. That's about it for simplification of complex numbers. So we're going to look at the operations with complex or imaginary numbers. The main thing to remember about these is that I is a square root. So I is a radical. It's square root of -1. Since I is square root of -1, if I square that square root, so if I square square root of -1, then the square and the square root cancel out, and I just get the -1. Okay, so I squared is -1. That's just a number. I itself, though, is a radical. When we're working with i's, though, we can start off by just treating them kind of like variables. We're comfortable with working with variables, so why not just continue? So for combining imaginary numbers, we just combine. 5i plus 2 minus 6i minus 7. We minus 1i. So minus I, minus 5. And that's it. I don't have to change it to radicals. I don't have to... Really, if it starts in I, you can just leave it in an I. Simplify as much as you can in the meantime. So if I have something like 3i times binomial 2 plus 4i, minus I times the binomial 7i plus 1, I can start off by distributing, getting stuff out of the parentheses. So let's see, 3i times 2 plus 4i would be 6i plus 12i squared minus I times 7i plus 1, so minus 7i squared minus I. Okay, I'm going to combine like terms, again, just working at it like it's a variable. So 5i plus 5i squared. Again, I squared is negative 1. So this is actually 5i plus 5 times negative 1, or 5i minus 5. And that's it. So wherever you see an I squared, it is just a number. It's more simple to have a number in there. So 5i minus 5. Let's try another one. Say I'm going to FOIL. 6i minus 5 times I plus 3. I can just FOIL, again, treat it like it's a variable. So 6i squared plus 18i minus 5i minus 15. Again, combine like terms, so 6i squared plus 13i minus 15. Again, I squared is negative 1, so where I see that I squared, I'm going to put in a negative 1. So 6 times negative 1 plus 13i minus 15 would give me 13i minus 21. 6 times negative 1 is negative 6. Minus 15 would be my minus 21. Okay, let's try another one. Say I have 2i plus 5 whole thing squared. It's a binomial. I have two terms. I know when it's a binomial, I write it out twice and FOIL it. So whenever it's a binomial, I know to do that. So 4i squared plus 10i plus 10i plus 25. Again, I squared is negative 1, so this is actually 4 times negative 1. So I'll have 20i plus 10i plus 10i. 4 times negative 1 is negative 4, plus 25 would be plus 21. And done. Okay, so what happens if we're dividing? Same thing that happens with radicals when we're dividing. If I have 6 over I, that means I have a radical. I is a radical. It's a square root of negative 1. So I have a radical in the denominator. I know then I need to simplify my fraction if I can. I can't. Simplify my radical. My radical is just I, so I can't really simplify that. And then just rationalize. So I'm going to multiply both top and bottom by that radical. So 6i over I squared. So 6i over negative 1. Can simplify the fraction now. 6 divided by negative 1 is just negative 6i. Let's try it again. Say I have 12 over 3i. I'm going to start off by simplifying the fraction if I can. I can. So 4 over I. Can't simplify the radical. The radical is just I. So I'm going to go ahead and rationalize. I over I. So let's see, 4i over I squared. So 4i over negative 1. Since I squared is negative 1. This time again I can simplify the fraction a little bit more. So negative 4i. And done. Going to go ahead and try another one. So I have 4 over 7i. Again, start off seeing if I can simplify that fraction. I can't. Can't simplify the radical. My only radical is I. So the only thing I can do is rationalize. So I don't actually need that arrow yet. I'm just going to multiply top and bottom by that I. When I'm rationalizing, I only have to multiply top and bottom by the radical. So I'm just going to leave the 7 as it is. So I'm going to get 4i over 7i squared. So 4i over 7 times negative 1. Or 4i over negative 7. That's it. Can't do much else. You could put the negative in the top if you wanted it, or put it in put it in front of the whole fraction, but it's fine like it is. Let's try last three. Say I have 3 plus I over 2 minus I. This time I still have a radical in the denominator. I have the I in the denominator, but I have a binomial. I have two terms in the denominator. I know when I have a binomial with a radical, that I need to multiply top and bottom by the conjugate. So I need to multiply top and bottom by the binomial, but change the middle sign. So I'm going to FOIL stuff out. I'm going to get on the top 6, so first will give me 6 plus 3i plus 2i plus I squared over 4 plus 2i minus I squared. So let's see. I'm going to get, well, I squared is -1. So I'm going to replace my I squareds with -1. On the top, I'm going to get 6 plus a -1, so 5. And then I have positive 3i plus 2i, so plus 5i. On the bottom, I'm going to get 4 minus a -1, so 5. And positive 2i minus 2i cancels. So I have 5 plus 5i over 5. Since 5 goes into both of the terms in the top, so my 5 here can divide into both of my terms in the top, that means I could factor out a 5 in the top and cancel it out. So I can say, instead of having to do the whole work of factoring it out, I can say, okay, 5 goes into 5 one time, 5 goes into 5i one time, leaving you with an I. So I'm just left with the 1 plus I. Okay, go ahead, try 2 more. Say I got 6 over 3 minus I. Again, it's a binomial on the bottom with the radical. So I'm going to multiply top and bottom by 3 plus I over 3 plus I. On the top, I don't have to FOIL this time. I can just distribute. So 18 plus 6i. On the bottom, I will FOIL. I will get 9 plus 3i minus I squared. So on the top, I'm going to come down here and I'm going to have 18 plus 6i. On the bottom, I'm going to have 9 minus I squared is -1. So 9 minus a -1 is 10 plus 3i minus 3i cancels. So again, I can simplify this a little bit more. I can say, hey, I have a number that goes into my 10 on the bottom, that also goes into both the numbers on the top, the 18 and the 6. Or I can think of it as factoring a number out of the top and seeing if it cancels out. Since I see that a 2 goes into all 3, I'm going to go ahead and divide a 2 out, get 9 plus 3i over 5, and done. Try that with the last one. I have 5 plus 3i over I minus 1. Again, I got binomial in the denominator, so I'm going to multiply top and bottom by the conjugate, I plus 1. So on the top, I'm going to get 5i plus 5 plus 3i squared plus 3i. On the bottom, I'm going to get I squared plus I minus 1. Okay, so on the top, wherever I see that I squared, I'm going to write a -1. So I really have 5i plus 3i is 8i. Then I have positive 5 plus 3 times -1. So positive 5 plus a minus 3. So 2. On the bottom, I have I squared is -1. So minus 1 would be minus 2. And then positive I minus I cancel. Again, I can look at the top and bottom and say, okay, there's a number, in this case 2, that goes into all of my terms. I'm going to divide everything, in this case by minus 2, so I can get rid of the negative at the same time. I'm going to go ahead and get minus 4i minus 1. Or again, you can factor a 2 out of the top. If you factor a 2 out of the top, you should get the same answer. Okay.